Good morning. Today is the 2nd of July 2023. Good afternoon. This is video number 393 and this video is based on cross-tabulation and chi-squared test statistic. So let me start with the chi-square test and let me introduce the schema presentation. I will introduce chi-square test, and in particular we will cover what is a chi-square test, how can we compute chi-square test value in SPSS, and how can we do that using cross-tabulation or two-way tabulation. This presentation is basically meant for those students who have an initial stages of knowledge in statistics. No previous knowledge is required, so this presentation and this lecture is very much simple. Chi-square test is a non-parametric test which is used to measure association between two categorical variables. Categorical variables are also known as qualitative variables or descriptive variables. We use it when we have observed frequencies of a qualitative variable, for example, educated and uneducated, and healthy versus sick, or gender, male versus female. There are two types of chi-square tests. One is a chi-square test of goodness of fit, and the other one is chi-square test of independence. So the chi-square goodness of fit test is used to compare the observed frequencies in a data sample with the frequencies based on some prior expectation, either empirical or theoretical. The second type of chi-square test, that is the chi-square test of independence, assesses whether the observed frequencies are dependent on or contingent on certain conditions or not. The chi-square test statistic is given by this formula. We can compute the chi-square test value using this formula, and this formula is used for both of the Pearson chi-square test statistic, that is the chi-square test for goodness of fit and the chi-square test for independence. In this formula, the symbol chi-square is a chi-squared test statistic. Sigma is the summation operator, O stands for the observed frequency, and E stands for the expected frequency. The larger the difference between the observations and the expectations, that is O minus E in the equation above, the bigger the chi-square test value will be. And if the chi-square test value will be bigger, then it will mean that the chi-square test is significant, and we reject the null hypothesis that there is no relationship between the two variables. So we conclude that there is some type of relationship between two categorical variables. The chi-square test statistic is compared with the critical value using a chi-square critical value table or statistical software. But now we don't need to use chi-square critical value table, because in every statistical software we can directly conclude whether the test value is significant or not, because the observed value of the p value is given there, and on the basis of the observed value we can conclude whether the test value is significant or insignificant. There are certain assumptions for the test of goodness of fit of the chi-square test, and the first assumption is that we should identify the variable and the level of measurement. So we must make it sure that the variables that we are dealing with must be categorical, qualitative, or descriptive, and the level of measurement is either nominal or ordinal. The second assumption required for the chi-square test statistic is that the data are obtained from a random sample. The third assumption is that the expected frequency for each category must be equal to 5 or more. And there are two relevant hypotheses. H0 is the null hypothesis, and it states that the two categorical variables are independent, or in other words we can say there is no relationship between the two categorical variables. The alternative hypothesis, denoted by H1, states that the two variables are independent, which means that there is a relationship between the two variables. If on the basis of the test statistic we reject the null hypothesis, then we conclude that there is some relationship between the two variables. We can have some practical examples using some hypothetical data from SPSS. So let me start with this file. The total number of observations in this file are 110, and there are two variables. One is education and the other one is health. So I have defined these variables in this way. Education is a categorical variable, and 1 stands for those who are educated and 0 stands for those who are uneducated. Similarly, for the health variable, we also have two categories. 0 stands for those individuals who are sick, and 1 stands for those individuals who are healthy. So both of them are categorical variables, and we can make a cross tab of these two variables. So in order to make a two-way table or a cross table, I'll go to analyze, and then I'll go to cross tabs, and in cross tabs this is already here, but let me take this out and take this out. So by default these two variables will be here. So let me send this variable as a row variable, and let me pull this as a column variable, and let me uncheck this. First I just want to make a two-way table of these two variables. So here is the case processing summary. Total number of valid cases is 110, and this is the two-way table of respondents by education and health. So we can entitle this table as classification of sample respondents by education and sick. This is 2 by 2. So these are the uneducated sample respondents, and these are the educated sample respondents. Total number of uneducated is 42, and total respondent of educated is the total number of educated respondent is 68. So the total number of all respondent is 110. Row wise, we measure health. The total number of sick respondent is 36, and the total number of healthy respondent is 74, and their sum is also equal to 110. So this is a cross tab or a two-way tabulation of two categorical variables. Education, in education we have uneducated and educated, and in health variable we have sick and healthy. So this is cross tab or two-way tabulation of two categorical variables. Now if you want to assess whether these two variables have any association between them, so we cannot say without using statistical test, and for this purpose we are using a non-parametric test, which is a chi-square test. And in order to do that, let me go back to the analysis, and I'll repeat the same procedure, but this time I'll click on statistics and I'll check chi-square. Now this time if I continue and press on OK, it will give me cross tab as well as the chi-square test value. So this table is the same that we made earlier without chi-square, but this time I have checked chi-square test, and the SPSS has given me the results of the chi-square test. So since I'm using Pearson chi-square test of independence, so its computed value is 11.920 and its two-tailed p-value is 0.001. So this means since this value is less than 0.05, so it means that this test value or this Pearson chi-square test value is significant at 1%, and on the basis of this p-value or significance value, we reject the null hypothesis of no relationship between the two variables. So we conclude that there is a relationship between education and health. So on the basis of chi-square value and its p-value, we reject the null hypothesis and we decide or we conclude that there is some relationship between education and health. So if you can, and we can guess from this table also, you see more educated people are more healthy and more uneducated are sick. So there is some kind of relationship between health and education. So this is how can we compute chi-square test. Ladies and gentlemen, this is very simple, and we saw that the observed p-value was less than 0.05, so we rejected the null hypothesis and we concluded that health and educated variables are associated with each other. My dear followers, subscribers, if you haven't yet subscribed to this channel, kindly subscribe to the channel and do not forget to the bell icon so that you can get timely notification about my other videos that I'll upload for you. I'm very grateful for watching this video, and I'll request you to share this channel and video with your colleagues, with your students, with your friends, so that they can also get benefit using this video. Thank you, and see you in another video. Thank you.